Today our topic is stack using linked list. So we've already learned linked list can be defined as collection of objects called nodes that are randomly stored in the memory. A node contains two fields, that is data stored at that particular address and the pointer which contains the address of the next node in the memory. The last node of the list contains pointer to the null and first node address is stored in external pointer or header. And what is stack? Stack is an ordered list of similar data type. Stack is a LIFO, that is last in first out structure, or we can say FILO, that is first in last out structure. There are two operations on stack. First is push operation. Push function is used to insert new elements into the stack and pop function is used to remove an element from the stack. Both insertion and removal are allowed at only one end of the stack called top of the stack. If you want to know more about stack and linked list, there are more videos about stack and linked list in this series. Please consult those videos. So, why stack using linked list is needed? We already learned stack using array. There is one video on stack using array in this playlist. Please consult that video, then it will be more clear for you. But today we will learn stack using linked list. So why it is needed? The major problem with the stack implemented using an array is it works only for a fixed number of data values. That means the amount of data must be specified at the beginning of the implementation itself. So in case of array, memory is allocated as soon as the array is declared at compile time. So it works only for a fixed number of data values. It is also known as static memory allocation. But in case of linked list, memory is allocated at runtime as and when a new node is added. It is also known as dynamic memory allocation. Stack implemented using an array is not suitable when we don't know the size of the data we are going to use. Means in case of array, we have to mention the size when we are declaring an array. So it is compile time allocation. But if the data size is not known, then we can't allocate the space at the time of compilation. That is the another disadvantage of using array. A stack data structure can be implemented by using a linked list data structure. The stack implemented using linked list can work for an unlimited number of values. That means stack implemented using linked list works for the variable size of data. So there is no need to fix the size at the beginning of the implementation. So when we want to add a new node in the linked list, we just create that node using dynamic memory allocation. So there is no need to fix the size at the beginning of the implementation. So the stack implemented using linked list can organize as many data values as we want. Stack using linked list. Before learning this video, please learn linked list video part 2, where we are already learned what is begin insert function and what is begin delete function for linked list. Actually here we are doing begin insert and begin delete of linked list. So stack follow which rule? LIFO rule. Last in first out, that is last inserted element will be deleted first. Actually we are doing in case of linked list begin insert and begin delete. So see, in linked list implementation of a stack, every new element is inserted as top element. That means every newly inserted element is pointed by top. Whenever we want to remove an element from the stack, simply remove the node which is pointed by top by removing top at its previous node in the list. So, this case is begin insert function and this case is begin delete function. And what is top? Top is actually the external pointer. The next field of the first element must be null because it is the last node of the list. Take one example. I want to insert 25, 32, 50 and 99 in our stack. So how you can implement this using linked list? First create one node. Info is 25, next is null. Now create another node whose info is 32. Next is the address of this node 25. Again create another node, info is 50. The next is address of 32. Again create another node, info is 99. Next is address of 50. Now say this node address is 1000. This is stored in external pointer or header. An external pointer has its own address, that is 600. Now see, this is the case of begin insert function. We already learned begin insert function in case of linked list, how to add a new node at the beginning of linked list. Okay. Here also in case of stack, because stack follow LIFO rule, here also in case of stack, it plays like begin insert function. So the last inserted node is 99 and the first inserted node is 25. Now see the discussion. Stack using linked list. I want to insert this node. Function name is push. I am passing the address of external pointer, that is 600. Say it is top. So I am passing top. So top is an address that hold another address and that is the address of the node. So top is 600 and the value which I want to insert. First time it is 25, then it is 32 in this way. That is I want to create one new node. That node info is X. Struct node star q means I declare one variable q that can hold address of any node. Now using malloc I create this node. So struct node star malloc size of struct node. So malloc allocate at the time of run struct node size memory chunk and it returns the initial address to q. So what is q? Q is, say this is our memory chunk. So q is 4000. Now if q is null, if q is null means in your computer there is no space, means your memory is full. You can't create any new node. Okay, so that is the case of full, means you can't create any new node from your computer memory. There is no space. So that is the case of full. So if q is null, means no space is there. We can't create a new node, means we can't allocate struct node size memory chunk. Okay, so just write one printf statement full. Otherwise, q arrow info equals to x. First time I want to insert what? 25. So x is 25. And q arrow next equals to start top. Start top means what? Value at top. Value at top. Initially there is no node, so external pointer holds null. So start top means value at top, it is null. So q arrow next is null now. And start top equals to q because this is our first node. So here you have to give 4000. In this way you can add your first node in your stack. And it is the case of begin insert. Next time, again I want to create another node. So using malloc, I create this node. Now this value is q, this 3000. Okay. So newly created node address is q. Now q arrow info is x. So it is 32. And q arrow next is start top. Start top means value at top, that is 4000. It is here. And start top equals to q. Now this is 3000. In this way, we can add another node. Next time this is our newly created node. So this is q. Using malloc, we can create and the initial address of this memory chunk is q. So q is 2000. Now q arrow info is x. So it is 50. And q arrow next is start top. Start top means value at top, that is 3000. And start top equals to q. So it is 2000. Next time again create another node using malloc and this node address is q. Malloc returns the starting address of this memory chunk, so it is q. So q is 1000. Now q arrow info is x. I want to insert 99. So q arrow info is x. Q arrow next is start top, so it is 2000. And start top equals to q. So here it is 1000. So in this way, you can add a new node in this stack using linked list. Now see, this is the case of begin insert. Now pop operation. In case of pop operation, here also you have to pass the address of external pointer, that is this 600. Here top equals to 600. Function name is pop and return type is integer because when I pop a particular node's info, then I have to return that info. First say I want to delete this node. Actually, I want to pop this node, means I want to delete this node and I have to return the info of this particular node. Okay, because Here in this linked list, all infos are integer, so return type is integer here. Int y, I declare one integer variable y, and struct node star p means p can hold address of any node. P equal to start top means value at top. Here value at top is 1000. So p is 1000. So actually p points this node. This node is p. First you have to check whether start top is null or not. See here start top means value at top. Here if it is null, say, then we can say no nodes are there, so the stack is empty, so popping is not possible, so return -1 because stack is empty. Otherwise, this case all nodes are there and I have to pop. Y equals to p arrow info. What is p? P is 1000. So p arrow info means 99. So y equals to 99. Start top equals to p arrow next. P is 1000, p arrow next is 2000. So value at top equals to 2000 because I want to pop this node. I want to delete this node. So now top points to the next node. So start top equals to p arrow next. That is 2000. Free p. That is I have to delete this node. And return y. I have to return this value 99. So return type is integer and I have to delete this node. So after popping, this is the situation. So this is the similar case of begin delete function in case of singly linked list. Again I want to pop. So p equal to start top. So what is p now? P is start top means value at top, it is 2000. So p is this node. Now if start top equals to null, is start top equals to null? No, it is 2000. So y equals to p arrow info. So p arrow info means y equals to 50. P is this node, p arrow info is 50. Start top equals to p arrow next. P arrow next means 3000. So it is start top now 3000. Free p. So I have to delete this node and return y. I have to return 50. Next time, when again I call pop function, p equal to start top. Start top means value at top, it is 3000, so p is this node. If start top equals to null, no, start top is 3000. So y equals to p arrow info. So y is 32. Start top equals to p arrow next. So it is 4000. Free p, I have to delete this node and return y. I have to return 32. Next time, when again I call pop function, p equal to start top. So p is now 4000. If start top equals to null, is start top equals to null? No, it is 4000. Y equals to p arrow info. Y is now 25. Start top equals to p arrow next. P arrow next means null. Here it is null. Free p. So I have to delete this node and return y. So return 25. Next time, when again I call pop function, first check if start top equals to null or not. See start top equals to null means the stack is empty, no node is there. So just keep one statement, printf stack is empty and return -1. So how we can implement stack using linked list in C. So this is our program, this is node structure, these are required prototypes. Push function is used for pushing any element into the stack. Pop function is used for popping or deleting from the stack, and display function used to see what is the recent position of stack after some pushing and popping operation. In main, I initialize extptr as null because initially no node is there, so extptr contains null. Now I start one do while loop. This is one index. Case 1 is push, case 2 is pop, case 3 is display, 4 is exit and 5 is default. Take the choice from the user. Now I use switch case control statement. Switch choice. Case 1 is push function. So first I have to take how many number of element user want to push. Say it is n. Then I start one for loop for I equals to 0, I less than n, I plus plus. Repeatedly take the info part of each node and call the function push by passing the address of xtptr and info of each node. Case 2 is pop. So call the function pop by passing the address of xtptr and this function returns the popped node or the deleted node info parts and I store it in the variable I and I print that value, that is I. And case 3 is to see the recent position of our stack. So call the function display by passing the address of extptr. Case 4 is exit and the default case. Now these are our function. This is our push function. We already discussed. This is our pop function. We already discussed. And this is display function. So this is our display function. Here I am passing the address of extptr. Stack node star p means p can hold address of any node. P equal to star ext means p points to the starting node. I start one while loop while p not equals to null. Till p not equals to null, I have to print each node info and I have to increase p by writing p equals to p arrow next. In this way, I have to print the whole linked list. Now I am showing the total program. This is node structure and prototypes. This is main. This is switch case control statement. This is push operation. This is pop operation. And this is display function. Pause this video, try to do it by your own. So when I run our program, supply your choice. I want to push case number 1. Supply the number of element you want to push, say 5. First element 11, then 22, then 33, then 44, then 55. Want to see the whole linked list or whole stack. So it is this. Now I want to pop. So stack follow which rule? LIFO rule. Last inserted element will be deleted first. So pop. So the popped element is 55. Now again I want to see our whole stack. So 3. So this is our stack now. Okay. Case 4 is exit. So this is your programming assignment. Write a C program to implement stack using linked list. Pause this video, try to do it by your own. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.